Okay, so it's the day 17 of doing Leetcode daily until I get a job. So today we are with the DP questions again, and the first question is coin change. So what we have in this question is you are given an array integer. So we are doing this thing again, and we have done these four, and next four are we are doing so. Next, the coin change. You are given a integer array coins representing coins of different denomination and one integer amount representing a total amount of some money. Okay. तो एक कॉइन्स का एरे है जिसके अंदर हमें कॉइन्स दे रखे हैं उनकी वैल्यूज़ के साथ, डिनोमिनेशंस के साथ, कि भाई इन वैल्यूज़ के कॉइन्स हैं हमारे पास. सेकंड इज द अमाउंट. Okay, now what we need to do is return the fewest number of coin that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have infinite number of each kind of coin. So using these coins we have to make up this sum. Okay, and with the minimum number of coins. So with the minimum number of coins, so how can we break this problem into smaller sub problems to apply dynamic programming to it? Is um, just let's assume that we have a sum which is 11, and we have coins 1, 2 and 5. Okay, so what we can do is simple to see. We have a given sum 11, that is our target. If we have the number of coins needed to make up 10, then we know that we just have to add one coin, that is 1, and it will be our target. Similarly, if we know the number of coins which are needed, minimum number of coins which are needed to make up 9, then we just have to add a 2 here. And similarly, if we know the number of coins needed to make up 6, then we have to just add a 5 here. So this is how we can do this, that we have to find the answer for smaller states, and then we can add them up to find the answer for bigger states. So let's start from the very start, and here we will take a 2D DP, which will be like this. Okay, and this will be of size. What will be size is, if n are the coins and sum is the we need to find, then it will be n plus 1 and s plus 1. See, why is it relevant is that this sum using these coins, and it will represent the number of coins we need. Okay, number of coins we need, the answer will be this. Okay, and we will be returning dp of n and sum. With n coin we need to find this sum. So what will be the answer? This will represent our answer. So how do we build up this answer? See, firstly, let's take out the corner cases first, that we have any number of coins, let's say any number of coins, and we have sum as 0. Let's start from sum 0. If the sum is 0 and we have any number of coins, how many ways are there that we can do that? There's no way we can do it, because our sum is 0, we don't have to do anything. Similarly, if we have no coins and we have to find out any sum, then it will be like we have to add up infinity of the coins with 0 to add up to I. Okay, that's just a okay, we are just supposing it, don't like take it seriously that this is true. So in max, like if infinity defines nothing, okay, it's basically a very large number, so we're just taking it as okay to find out the answer. See, it will basically form a 2D table kind of thing. What kind of table it will be is that see, here we have these kind of columns and rows, and what do these suggests? Let's see what do these rows and columns suggest. So if we take this side represents the number of coins n, and this side represents sum, it will be 0, 1, 2 up to sum. It will be 0, 1, 2 up to n. Okay, now if the sum is 0, coins are 0, what will be the answer? Sum is 0, coins are 0, then it will be infinity. Similarly, what will be in this row? If coins are 0, sum is anything, it will be infinity itself. And if the sum is 0, we have number of coins, it will be 0. Now we just need to find out for the rest of the columns, rest of the cells basically. Okay, so dp00, let's take it as 1. That I will not take it as infinity, let's just take it at 1, because we have the coin also 0. Okay, one way is that we will do nothing and it will be fine to us. Now what will happen when we have sum 1 and we have one coin available? What will be that case? We will check that if see, for the rest of the cases, what we will be doing is, let me just explain the first the concept, and after that we'll be going to the table. See, what we'll be doing is, whenever we are at any sum, let's say j is that sum and I is the coin. Okay, I is the index in the coins array which we are considering. So if coins I, ci, is less than the required sum, less or equal to, only then we will be taking it, right? Because if we have the sum as 5 and we have only 1 and 2 coins, how can we take this if we have a sum of 2 and we have a coin of 5, is there any way we can do something? No, we cannot, because sum is less than that coin, so we will just ignore that coin. Okay, so in that case, if this is the thing, that coins I minus 1 is coin I is less than j, that coin is a valid coin, we can take in our answer, we can consider it, then it will be just dpij. What will be the answer in this case? With this much coins and this as our sum, what are the possibilities is, we have to find the minimum answer. So it will be min of two things. Do we have to, first thing, do we have to take the current coin, or do we not have to take the current coin? Right, so it will be like dp, we do not take the current coin I minus 1j, or we take the current coin. If we take the current coin, it will be 1 plus, and we are taking the current coin, so it will be I. And what will be the sum now? If we have took the current coin, if we took the current coin, this sum will be decreased by the value of it, coins I, right? Its value will be decreased because we have considered the current coin. So that's how it is done. And if this condition is not true, if the coin's value is greater than the sum, we will just simply ignore this coin. So dpi j will be dpi minus 1 j. Sum will remain same, coins will remain same, coins will be decreased by 1 because we are not considering the current coin. So this is how we can think of it. Let's fill the table now. If the sum is 1 and coin is also 1, so it will go into this condition. If we go into this condition, it will be minimum of dpi minus 1j, just the last row above it, it's 0, I minus 1j, and what will be 1 plus I, j minus 1. It will be, this term will be 0, j minus coin I, and this is 0 already, so 1 already. So dp10, 1 plus dp10. What is dp10? First row, it will be minimum of either to this dpi minus 10. I is the coins, coin side I minus 10, so we are just taking the 1 and 1, right? So I minus 1, 0, 0, 1, 0, 1. Is it the infinity? Minimum of this is infinity, and this thing is 1 minus, so it will be 1 plus dp I is 1. Okay, I is 1 and this will be 0. Okay, so 1 plus dp 1 0. First row, yeah, first row and 0th column. It was also this, right? What is was 0 and 1. Sorry. Yeah, it was 0 and 1. It was dpi minus 1j. What it was? It was actually, see, we have to take see, this is causing a thing here that this thing is what? I minus 1, dp 0 and 1, dp 0 0. This is a 0 and 1 1. This term is 0 actually, not infinity. You're mistaken. And this term will be 1 plus dpi 1 plus dp 1 and 0. So it will be coin I. If that coin is less than that sum, we have the sum is 0 as 1 and 1. We'll take the coin 0, right? Coin 0. Yeah, I mean, hmm. Hmm. We are checking for I is equal to 1, j is equal to 1. And it will go up to n equal to n. So we have to take I minus 1 because we have a coins array which has number of element is n minus 1. So it must be I minus 1, right? So if coins I minus 1 is less or equal to j, if coins I minus 1, C0, C0 is what? Let's say these are 1 to 5. 1 is less or equal to 1, yeah it is. Then dp11 will be equal to minimum of dp01 and 1 plus dp10. dp01 is 0 and dp11 is 10 is if we have any number of coins, if the coins we have but sum is 0, coin is 0. Okay, guys, these value are 0. We have coins but sum is 0. No, we have, sorry, we have coins as 0 and sum is something that will be infinity, and we have sum as 0. We have sum is 0 and coins are changing. Yeah, that will be 0 and that will be infinity. So what will be this? 1 and 1 must give answer 1. We know that logically that if sum is 1, there is only one way to do it, which will be one coin of 1. Okay, so how do we do this as a 0th row? No, the columns must be infinity. So it is like that. If sum is, see, n plus 1 sum row and column, so this must be n. Oh my god, we mistaken it, and this must be sum row and column. This is how it works. Okay, we were actually made the table of sum dp sum and n, and we were calculating it for dp n and sum. So it was actually, that's why it was happening. It should be 0 on this side and this should be n and infinity on this side. And why is this? Simple. And now if we take dp1 1 plus dp10, dp10 is what? First row and 0th element 0, so 1 and infinity. If we compare 1 and infinity, and what is minimum? This is infinity, this is 1. So answer will be 1 here. That's why we were taking opposite thing actually. We made the table, what do we say, that transposed. Okay, that's why the problem was happening. Now let's take, if we have sum as 1 and sorry, coin is 1 only and sum is 2. If sum is 2 and coin is only 1, we know that either we can take a 2 rupees coin or we can take 1 and 1. So there are minimum number of coins is 1. So how do we find that? We can find it like firstly, but there is only one coin up to now. We haven't took the 2 rupees coin, so answer up to now will be 2 only, right? Let's see now. We have to find this answer, nn sum. Okay, we don't worry about all these, it will be automatically calculated. So we'll do this only, and after that we will write the code. So for this cell, when we have a 1 coin and 2 is the sum, if 2 is the sum, we can see that coin I minus 1 is less or equal to the sum. Yes, it is. So it will go into this condition, and dpij means dpi is 1 and j is 2. It will be equal to min of dpi minus 1j means dp0 to 0. And another thing is adding 1 and considering the current coin. Okay, it will be dp 1 and 2 minus 1 1. Do we have a solution with 1 coin and 1 as the sum? Yeah, we do have. 1 is the solution, so it will be 1 plus 1 2, and this is infinity, so minimum of 2 and infinity is 2, so this will be 2. But when we will be here, it will return 1 because we have a coin of 2 also now and 1 also, and we have 2 here. 2 sum and 2 rupees coin is available, so it will be 1. So that's how it's done. Let's try to do the solution now. That int n is coins dot size. Okay, and let's make a dp of n plus 1 and sum plus sum is the right. Okay, do it as sum plus 1. Yeah, this is the way we did it, right? Now fill the borders. Oh, actually fill the first row and first column. So int i0 to I less than or equal to n I plus plus. If we are changing the coins, then dpi and sum is 0 always. If sum is 0, okay, then it will be 0. Similarly, if we have the coins as 0, we have no coins and we have to get to sum any number of sum, then it will be int max, and we'll do it minus 1 to prevent the outbounds. Okay, and dp00 is again 0. It will be done infinity in this case, but we will again do it 0, sorry 1. Now let's start the loop for I is equal to 1 to I less or equal to n I plus plus, and let's take the sum for loop, and j is equal to 1 because for 0 we have done it already. J is basically we are starting from here, starting from this to, we will populate all these. J is less or equal to sum j plus plus. So now what was the condition is that if coins I minus 1, that coin we have is less or equal to the sum we need to find, then only it's a valid point, right? Considering this, and we have to find the minimum if we take this coin or do not take this coin. See, either we can ignore this coin, that we don't want to take this coin and still find the sum j. Where is it? It's just the upper row. I minus 1 is the upper row. Okay, we do not take this coin, we will be doing with these available coins only. And can we find this sum 1? Yes, we can also find this with this too, but for it uh, we have to find the minimum, right? Either this or this. Which one is minimum? We will take that. So either we ignore this coin or we take this coin. Taking this coin will be 1 plus dpi. Taking this coin and decreasing its value from the sum. That we have took this, so the value will be decreased. Now we have to find a lower sum now. Else, if the coin is greater than that sum, then obviously we won't take it, and the answer will be same, dpi minus 1 j. Fine. So now if what will be our answer is, see, if dp and sum, if it is not equal to minus 1, if it is equal to minus 1, sorry, int max minus 1, int max minus 1, that means that we do not have a valid answer actually. So we'll be returning minus 1, else we'll be returning, so we can do this like yeah, we can do this and return, if this is this, then minus 1, else dp and sum. Find, yeah, let's try to do this. Yeah, fine. Let's go to the next question. Card de. Okay, so we have the palindromic substrings next. So given a string S, return the number of palindromic substrings in it. A string is palindrome when it reads the same backward as forward. We know that. So we are given with a string and we have to return all the palindromic substrings possible in this string. So how to break this question into smaller pieces is that, let's say we are given a string A, B, C, D, and D. Okay. If this is the given substring, one thing we know for sure, like how can we break this thing is, obviously we break it into smaller pieces. What is the smallest piece we can break is one character at a time, right? So if we take A, B, C, D, A, D differently, like separately, obviously every character, if we have a single character, it is palindromic. We know that single character is palindromic in itself. So we know that it's just a palindrome. This is the one length string. Now we will take a two length string. We will take all the possible two length substrings and see if they are palindromes. See if AB is palindrome, no. If BC is palindrome, no. If CD is palindrome, no. If DA is palindrome, no. And if AD is palindrome, we'll check all of them. Fine. Now we will search for the three length palindromes, and similarly we will do for all the possible lengths. And how will we do this is, for one, it's simple. We will take a 2D dp. It's, if its size is n, then it will be just simply n, okay, and n size dp, and this will be a boolean dp. Basically the table will be filled with true or false now. Okay, and what does this signify is that dpij will be what? dpij will signify that starting from I ending to on j, if this substring is palindrome, this value will be true, else it will be false. Substring from I to j in this overall string, if it is a palindrome, it will be true, else false. So for 1 and 2 lengths, it's simple. For 1 length, we just have to go to each character. We'll turn everything true in that, because every character is a palindrome in itself. Then we'll go to 2 lengths. We will check if si is equal to si plus 1. Then we will do it as true. dpi and I plus 1 is true. Otherwise, we will just go forward with it. And every time we find a palindrome, we will just increment the count, because we have to return the number of palindromic substrings. Now if we start from length 3, now that's where we need to do something. See, for the 3, if we have a dpi minus, if we have a dpij, we have to find is it a substring, and its minimum length is 3, means I minus j is I minus j plus 1 is equal to 3. These are obviously indexes. Okay, I minus j. Yeah, sorry, j minus I, actually j is larger, j is a later index and I is earliest index. J minus I, so it will be, yeah, actually if it is equal to 3 or equal or greater or equal to 3, then we will check. So what is the condition that dp, so let's take this substring first, abc, 3 length. What is the condition when it is a palindromic substring is that we can start in this way that if dp I minus 1, I plus 1 and j minus 1, what does this signify? It signifies I plus 1 and j minus 1 means this substring's inner part. If we just ignore the boundaries, it will be the inner part, right? So dpij is what? This is I, this is j, I to j is this a palindrome. We will see if the inner part is palindrome. If the inner part is palindrome, then only we will go for the outer part, right? And let's say this is true, that inner part is palindrome, then what we have to check, if this last two characters are equal, if these two are same, then this is a palindromic. So we have to just check si equals to sj hai agar, then we will make this dpij as true, else we will make this as false. Okay, simple thing. Let's try to code this. So int n is s dot size, and let's form a dp. It will be a boolean dp, and initially everything is false. And how do we do that is using the memset. Memset and name of that vector, and it's basically what we have to do the value initially, so it should be false. And third is size of dp. Yeah, this is how we set all the elements to one value initially. Okay, so see, up to here there is no problem, right? We will take the first one length substrings first. From I to I, this one character only, they are always true. We will take them two characters, I or I plus 1 are equal, then if they are equal we'll take it true and increment the counter. Now let's check for 3 size and further. So for the size will be 3 to n k plus plus. For the further sizes we will check, and how do we check it is we'll iterate the array from 0 to I less than n minus k plus 1 I plus plus. Why we are doing this n minus k plus 1 is that, see if this is the uh, I and j, and we are talking about 3 size. Okay, then if I is this, j will be plus the 3 size, 3 minus 1 size, j will be here. If I is here, j will be here, d. If I is at c, j will be at a. If I is d, j will be at d. But if I is there, there will be no d for the 3 size, so we, and that will be invalid, right? It will be out of the bounds of the for loop. So that's why we are taking this. Like if the size is 6 minus 3 plus 1, up to there we will reach I, and j will be plus k minus 1 to I. So j will be ending, yeah, ending index will be of substring is I minus k plus 1. If I is 0, I plus k minus 1, actually I plus k minus 1, sorry, yeah. If I is 0, then it will, yeah, do the thing. So after that we have the starting index, we have the end index. What we have to check is if dp I plus 1 and j minus 1 means the inner substring is palindrome and the outer two characters, the boundary characters, are equal, then we can, not 3, it's on JavaScript. If they are equal, then we will do what, as dpij is true, dpij is true, and we will be c++, and that's all. We just need to return the count here. Yeah, that's it. What? What is this, man? I mean, I don't know why this happens, but fine, we'll make a vector then. Bool dp and n vector bool and all values are false. I is running 0 instead of I should return. So why is it happening as initially all of the vector is false. We said dpii is true, and we said dpi is true if si is equal to si plus 1. Perfect. Increment the count. If we try to see out dp 0 and 0 here, what do we get? That's 1, correct? If it is correct, It is correct. Yeah, okay. And 1 0 should be 0. Fine. Okay. Um, then I guess. What is the video running fine? Let me see. Yeah, it's 35 minutes already. Fine. If how many palindromes are there? Three are there. So let me see. So why is it returning 0? It may be because we're counting it here, we're counting it here. Okay. Wait, what is in the second case? Second case, our answer is 3. It must be 6. So we have put a counter increment for length 2 and further, but we haven't counted the ones here. Okay, okay, got it, got it, got it. This was just missing. Yeah. Perfect. What happened? Okay. Okay. Got it. Next is longest palindromic substring. Given a string has the longest palindromic substring. So we found all the substrings here. Now we have to return the longest one. So we can apply the same approach here. Actually, we can apply the same code here. Okay. What we can do is um, and size. Okay, okay. Instead of this, we will take the starting index of our longest thing, and we will take the length of it. So we will take two things, and max length. Maximum length will be 1 at least. Okay, because each character is palindromic in itself. Whenever we get a palindrome, we will do two things now. First thing is in this case max length will be obviously 2 only, because we are checking for 2 only, and starting index we can set to I. But in all the other cases, whenever we find a palindrome, we have to do what? If this current length which we are finding k is greater than the max length, we will do what? Max length is equal to k, and it will be start will be I. So now we just have to return what? The s dot substring starting index is start and length is max length. I guess that should do the thing. Yeah, exactly. That was easy. That was easy because, yeah, that's the same approach here. Now, last question is the decode ways. You have intercepted a secret message and coded a string of numbers. The number is decoded via the following mapping. 1 is decoded as A, 2 is B. Similarly, every number has its alphabet. Okay, however, while decoding the message, you realize that there are many ways to decode the message because some codes, okay, 2 will have a different decoding, 5 will have a different, and 25 will have a different, and we have to find that out. Like EEGF 11106 can be decoded in like AAGF 11106 or 11106, but we can, the grouping 11106 is invalid because 06 is not a valid code, only 6 is valid. Okay, so in that case we can know that okay, only the numbers from 1 to 26 are valid with no preceding 0, no 0 in the prefix of it, and only from 1 to 26. So how can we decode this? So same way as we have done earlier, what we can do is we can break this string in smaller parts, like we did in the palindromic question, that we will just bring this string in smaller parts, and what we can do is, see, if the length is if we'll take the length as n. Okay, I will have a dp. What will dpi suggest here? DPI basically suggests that how many ways it can be decoded when its length is up to I. Total length is n. What how number of ways of decoding up for length I. We have to find out for length n. So DP will be starting from 0 and will be marching up to n. Okay. So you know that if length is 1 and is 1, then we will return 1, but we will return 0 if it is 0. If the string is this, we will return 0 because 0 is invalid, and if it is any other number which is valid, basically empty नहीं है and एक character है उसमें और वो 0 नहीं है, तो it is valid, so we return 1. Fine. Then what will be dp0? For length 0 there is one way. For length 1, if there is only one character, again there is one way. Rest of it we will calculate. And how do we calculate this? We will run a loop from 2 to equal to n, starting from 2 ending up to n. And what will be happening is, at each stage we know that there are two possible cases. So see, if it is 1 1, two possible cases are there, either 1 and 1 separately or 11 collectively. So there can be one digit number or two digit number. In both the cases can be our valid points. Okay, one digit number, two digit number. So at every point we will consider both the cases. Let's consider the first case one digit number, and then the second case is two digit number. So one digit number will be simple SI. But remember one thing, SI, one digit number, it should not be 0. If it is 0, then we have to merge it with someone, and if it is not possible, then it will be invalid. Okay, so if it is something and not equal to 0, then dp will be what? Dp of I will be plus is equal to dp I minus 1. जो पिछला आंसर था dpi माइनस 1 का, वही dpi के अंदर ऐड कर दें, क्योंकि इनिशियली तो सबकी वैल्यू 0 है ना. dp1 0, dp2 भी 0, dp3 0, इनिशियलाइज हमने 0 से कर रखा है. ठीक है, तो dp1 dpi हो जाएगा, dpi प्लस 1 को ही उसमें ऐड कर देंगे. ठीक है, और ऐड क्यों करते हैं कि भाई dpi प्लस 1 अगर पहुंच गए हैं तो उसी वे में इसको हमने जोड़ दिया. ठीक है, लेकिन अगर टू डिजिट नंबर है और वो 1 से 26 के बीच में है, ठीक है, तो हम क्या करेंगे, तो हम ये करेंगे भाई dpi जो होगा ना प्लस इज इक्वल टू हो जाएगा डी पी आई माइनस टू के। और आई माइनस टू क्यों? क्योंकि आई माइनस वन को तो हम कंसिडर ही नहीं कर रहे हैं ना, तो हम पहले डी पी आई माइनस टू तक थे, उसके बाद हमने दो डिजिट इकट्ठी ले ली, तो इसलिए हम इसमें आंसर में जैसे ये डिजिट है, ये थी एक और एक पीछे थी, ऐसे कर करके थी, तो हमने यहाँ तक का आंसर निकाल रखा है, यहाँ तक का, तो हमने इन दोनों को तो एक में कंसिडर कर लिया। तो डी पी आई विल बी आई माइनस टू जो था उसमें हम उसी को हम इसके आंसर में जोड़ देंगे डी पी आई के में, ठीक है। तो ये जब दो डिजिट एक साथ लेंगे, जब एक साथ लेंगे और दोनों आंसर्स को हम डी पी आई में ऐड कर देंगे, डी पी आई विल बी आवर आंसर फॉर दैट केस। लेट्स सी हाउ आई एम टॉकिंग दिस, बट इफ int n is s dot size, okay, if n is 0 या फिर काम कर रहे जो इफ n is 0 या तो वो खाली है और s0 is 0, पहला ही नंबर जो है वो 0 आ गया, तो बेसिकली दिस, देन वी विल जस्ट रिटर्न 0 राइट, दिस इनवैलिड। पहला 0 तो नहीं आ सकता ना, आती कर दो फिर और कदम। फिर आगे हम देखेंगे, एक वेक्टर बना दिया हमने, वेक्टर इंट का डी पी एन प्लस वन साइज का, इनिशियली सबकी वैल्यू 0, ठीक है। अब हम क्या करेंगे, हमने देख लिया भाई, ठीक है। अब हम इसको इनिशियलाइज करेंगे, कुछ वैल्यूज को डी पी 01 and dp1 be 1. Now for 2 and further values int I is equal to 2 से I is less or equal to n तक, I प्लस प्लस तक क्या होने वाला है कि हम चेक करेंगे। पहले देखते हैं int वन डिजिट क्या बनती है हमारी, ठीक है। वन डिजिट क्या बनेगी भाई, करंटली हम इसको ले रहे हैं i माइनस वन वाले कैरेक्टर को और उसमें से 0 माइनस कर रहे हैं हम, अब जो भी आएगा, ठीक है। इफ दिस वन डिजिट इज नॉट 0, 0 नहीं होनी चाहिए बस, बाकी सब केसेस में बढ़िया काम से हो जाएगा। प्लस इज इक्वल टू डी पी आई माइनस वन कर देंगे, माइनस वन वाला जो आंसर था वही इसमें ऐड कर देंगे भाई, ये भी वैलिड है, इसको आगे बढ़ाओ फिर, ठीक है। लेकिन अगर इन टू डिजिट देखते हैं आप, टू डिजिट में क्या होगा, एस डॉट सब एस टी आर सब स्ट्रिंग, कौन सी सब स्ट्रिंग, स्टार्टिंग इंडेक्स क्या है आई माइनस टू, लेंथ क्या है 2, ये एक सब स्ट्रिंग हो गई। अब इसको हमें कन्वर्ट करना है इंटीजर में, तो एस टी ओ वाई हो गया। अबे ये क्या है, ओके, I'll convert this actually, ठीक है, एस टी ओ आई स्ट्रिंग टू इंटीजर। और अगर इफ दिस टू डिजिट इज ग्रेटर और इक्वल टू 1 एंड टू डिजिट लेस और इक्वल टू 26, इस रेंज में है, तभी वी विल डू व्हाट, डी पी आई को फिर से कर देंगे, इसमें ये पॉसिबिलिटी भी जोड़ देंगे भाई। दोनों केसेस पॉसिबल, हमें तो टोटल केसेस निकाल लेना, नंबर ऑफ वेज निकालने हैं, तो एक वे ये हो सकता है जब हम एक डिजिट लें, एक वे हो सकता है जब दो डिजिट इकट्ठे ले लें, तो दोनों को हम इसके अंदर जोड़ देंगे। एंड विल जस्ट रिटर्न डी पी एन डन। सी इट इज़ वर्किंग लाइक कि भाई 111 है मान लो, ठीक है। डी पी 0 क्या हो गया, 1 हो गया, डी पी 1 क्या हो गया, 2 हो गया। अब 2 से शुरू किया हमने, तो डी पी 2 से जब हमने शुरू किया तो हमने क्या चेक किया कि पहले तो एक वन डिजिट लेते हैं, वन डिजिट आई इज इक्वल टू कहाँ से शुरू हुआ, 2 से शुरू हुआ, तो हमने पहले चेक किया एस आई माइनस वन, एस आई माइनस वन क्या है, 2 माइनस वन 1, ये वन डिजिट में कंसिडर कर सकते हैं भाई। तो डी पी 2 क्या हो गया, पहले तो हमने डी पी 2 में क्या जोड़ दिया, डी पी आई माइनस वन क्या है 1, ये 1 है, तो 2 1 हो गया। अब हमने चेक किया कि क्या इसको और इसको हम इकट्ठे ले सकते हैं, i-1 और i-2 को ले सकते हैं। क्या ये 0 26 के बीच, 1 26 के बीच में है भाई? तो इसके अंदर डी पी आई में डी पी i-2 भी ऐड कर दिया, डी पी i-2 में डी पी 0 1 भी ऐड कर दिया। तो दो तरीके हो गए जब तक लेंथ स्ट्रिंग की 2 है। तो दो लेंथ की स्ट्रिंग क्या है, ये है। तो इसके दो तरीके कैसे हैं, या तो इसको 1 1 ले लो या 11 ले लो, हो गए दो तरीके। अब यहाँ पे आते हैं हम DP3 में। अब DP3 में क्या हुआ कि हमने देखा कि क्या 1 डिजिट ले सकते हैं, इसको ले सकते हैं भाई, ठीक है। क्या हम पिछली 2 डिजिट्स को ले सकते हैं इकट्ठा, ले सकते हैं भाई इसको भी। तो DP3 में क्या हुआ, पहले तो हम 1 डिजिट लिया, तो DPi-1 को ऐड कर देंगे इसके अंदर, वो क्या है 2 2। अब जब हम 2 डिजिट एक साथ ले रहे तो DPi-2 को ऐड करेंगे, यानी DP1 को ऐड करेंगे 1। तो नंबर ऑफ वेज कितने हो गए, 3 हो गए भाई। अब 3 हुए कौन कौन से भैया, तो 1 1 1 ले लो, या 11 1 ले लो, या 1 11 ले लो, हो गए ना 3 तरीके। सो दिस इज हाउ दिस क्वेश्चन इज वर्किंग एंड let's try submitting it. Okay, something is missing here. टेन का एक पॉसिबल आंसर होना चाहिए। पहली चीज DP0 DP01 और DP1। ओके, DP1 तो जब 1 डिजिट है, s-i 0 -0 stoi, ओके stoi DPi 1 है, गॉट इट। DP1 1 है, DP0 भी 1 है, फाइन। एन तक गए हम, आई प्रेस किया, 1 डिजिट चेक किया पहले हमने, 1 डिजिट वाले, ठीक है, और फिर 2 डिजिट वाले चेक किए कि इंट 2 डिजिट क्या होगा, STY सब STR-i-2 से 2, i-1 से 2 नहीं भाई, 2 से 2 एक्चुअली, यस, इट शुड वर्क फाइन नाउ। क्या हो गया भाई इसका, why is that not running, I don't know, let's reload this. I guess my internet is slow, I guess, let me check. Current internet speed is, yeah, it's fine. Okay, let's submit this now. Two, one. Okay. Yeah, internet is fine. Why is it? Okay, my this page is still stuck. I don't know. Wait a second. Let me just check. Mm, yeah, it's fine now. Okay. Okay, so let's check it again. Where can we? So in this test case, what will our solution do is dp0 and dp, okay, we'll solve with dp2. dp2 we have to find dp4. Okay, dp2 will be, okay, dp0 we have calculated 1, dp2 will be, we'll go here si plus 1, s1 first length 1. Okay, 1 is valid. Okay, so dp2 will be 1, and then we check the second digit, 1 into 21. Yeah, it's fine. Then it will be 2, I minus 2. So 1 plus 1, 2 will be there for 21, up to 21. Next we will check 0. For what will be for 0 is, next character is 0. If is 0 will not go inside this. Then we'll check this. That's 2, 0 and 1, 10. Yeah, it's fine. Then it will be dp I minus 2. I minus 2 will be 3 we are calculated, so it will be 1. So it will be 1 only. 1 for up to this. Now let's go to this 1. Yeah, it's fine. So it will be dp4, 2, 3 and 4. Okay, dp4 will be 1 digit, fine. So dp4 will be 1 was the last time's answer, so 1. 0, 1 will not be good to see. Okay, but what in the case, okay, 2 digit cannot be greater than 1. How can it be greater than 1? It should be greater than 10 and less than 26. So it, okay, fine. Why? Okay, 2 digit cannot be, like, if this is this was the error. Then see, if we take this string 0 and 1, what will it convert it into? 2 digit will be 1, and we were checking this condition and it was not fine, so it was passing into it further. Okay, so 2 digits must be of 2 digits. What does it mean? It must be 10 to 2 digits. Yeah, fine. Now this should work fine. Yeah, good. So yeah, these were the all 4 questions we did today, and we took 57, almost an hour to do so, because these were really good questions, like the best questions of DP, best, not best, if not best, but most asked questions of DP they were. So it was quite a good experience to solve them all. Yeah, tomorrow we'll come again and we'll solve the rest of the questions. 4 questions are left, we'll do all 4 tomorrow. So that's it for today. We'll meet tomorrow on day 18th.